Okay, today, go out of the way. All right. So today we're going to be dealing with the trig functions. Today we're actually moving on to section 4.2 and 4.3 today. These are the sections we are messing with, two sections back to back, just because they're dealing with the trig functions in general, and I want to make sure that we know what we're doing here. So trigonometric functions. Okay, now the good news is, trigonometry is the study of right triangles. We've talked about right triangles quite a bit in geometry. We talked about right triangles a little bit in Algebra 2. But I want to talk about what we're going to be using them for the first part and what it's going to eventually mold into today. So, let's start with the actual trig functions themselves. There's 6 main functions we need to know. So we're going to go through the names today. We're going to go through how to draw them and how to use them today. Okay? All right. So the main part here on the main names of your trig functions. And this will be probably one of the few days to actually write out the full names. Sine.
Cosine.
Cosine.
Tangent.
Tangent.
Invert sine. Inverse sine. Inverse cosine. Inverse tangent.
Which is called
Are you going off on a tangent right now?
cosecant, secant, and cotangent. These are the actual correct names that you're going to see. Now, they have abbreviations.
Why'd you write them in a different order?
It didn't matter. I'm putting the 6 main. The main 3 are the first ones. These 3 down here are supposed to be matched up letter for letter. So, cosecant goes with sine, secant goes with cosine, and cotangent goes with tangent. So, it's always, every trig function, every main trig function is always matched with something that starts with the letter C. At least one of them has to have a C in it. So, secant has to be paired with one that starts with the letter C. Cosine already has a C in it, so it has to be matched with the one that starts with S, and then the tangent has to be matched with something that starts with C, cotangent. So every pair has to have one that starts with the letter C. That's how I always think of it.
Why?
So that's just the way they work. Okay? Alright, but again, this is the order, and they're matched in correct order. Okay? Alright, now, the names. Other than the main names, like the full unwritten, we have abbreviations for them. Yep, sine, cosine, tangent. So these are the main 3 buttons on your scientific calculators, graphing calculators. Cosecant is CSC, and then secant is SEC, and then cotangent is COT.
Can you just put like the -1 power or whatever?
Those, when you put a -1 on them, that means something completely different, which we're going to talk about today.
What about on your calculator when you hit the thing?
No, when you use a little -1 like tangent -1, it is not these 3.
When you hit the second though?
Yeah, it's not those 3. That's the part that people get wrong.
Completely different.
That's completely different. Yep.
They're different.
So that's what we're going to talk about today. I want to talk about like what these functions are. How would you actually get them on a calculator? Like how would you actually find the results of these and what are they used for? So that's kind of the main idea today. But let's talk about the main 3. Okay. Now how I always work with these main trig functions. This is the little acronym system that I always have in my head. SOHCAHTOA. Yep. It's just, if you can have this simple acronym memorized, you can get to every possible combination of answers for all 6 of them. Okay? And what they're used for. The main capital letters there are the trig functions, the main 3. The main 3 are these. These are the main 3 trig functions. The ones that everyone knows. They use them all the time. The others are what they call the reciprocal functions. They're actually the flips. Reciprocals, it doesn't use the -1, that would be called an inverse function. We'll see those later. These are called the reciprocal functions. We flip them over. But again, the sine function, the S, that's what that S stands for. It stands for sine. It's sine of an angle. So what that means is the button on your calculator is pre-programmed that when you type in the sine of, let's say, 30 degrees, it is pre-programmed to know the fraction that comes after it. That's what it's programmed for. It's programmed that when you type in the sine of some angle, it knows it's going to take the opposite wall of your right triangle and divide it by the hypotenuse wall. It's pre-programmed to know that. So when you type in sine of 30 on a calculator, it will automatically tell you 0.5 on the screen. Because it knows the walls are in relationship that the opposite wall is whatever the length is, they call it the 1 unit wall. The hypotenuse will always be twice as long. So when you divide them, you'll get 0.5, you'll get half. It's pre-programmed. Because on right triangles, the walls and angles are in direct relationships. So whatever the angle is, the walls are already set. They're pre-scored to be a certain particular number, or they're scaled to be the same. Because some people are like, well, what if I just draw a bigger triangle? There's a scale, there's a multiplier that would actually get you to that number. So we could simplify, because fractions always can simplify. But again, the letter system on SOHCAHTOA is what we remember. So it's sine, opposite over hypotenuse. That's why they have O and H. The second letter always goes on the top of the fraction. The third letter, I should say, always goes on the bottom. And the letters in the back are always the walls of your triangle. The first capital letter is the trig function. So what I mean by that is on a triangle, a right triangle, here's my right triangle, the walls, wherever your angle sits, other than the right angle, so it has to be one of the acute angles. Let's say theta is sitting here. Theta is a Greek letter for an unknown angle. Whatever this angle is, the walls are called a certain name from that spot. So this is the opposite wall of that angle. It's, opposite means across. It's the opposite side of the picture. This wall is called the adjacent wall, which we haven't had to use yet. And then the hypotenuse is always the biggest wall. The hypotenuse is always the largest side of a right triangle. Okay, questions on the names of the sides of your triangle, why these come into play? Yep. Now, do we see how the OH, AH, and OA fit? Do you see where the names come from? O and A's come from this picture and H's. So, sine is the opposite over hypotenuse, and again, what we're gonna talk about today is, other than setting up our triangles, what do we use it for? That's gonna be the hands-on thing today. Like, why would we use sine of 30? What would be the purpose of it today? So that's hopefully the goal, and we're gonna do a little bit of hands-on with that. Okay? All right. But that's sine, that's the first trig function. Now, the second one is cosine. So cosine, or the C here, cosine, so it's COS, cosine of an angle, whatever angle you type in, it's going to automatically on your calculator give you the adjacent wall, and it's going to divide by the hypotenuse. So A over H. So the adjacent wall, whatever that length is, it'll take it and divide by hypotenuse, and it'll always divide. So if you do 30, if you do that 30 degrees like I showed you earlier, the calculator will automatically be pre-programmed to take the square root of 3 and divide by 2. Now again, I'll explain that once we get going here, because certain triangles have certain specific lengths, like 30 degrees and 60 degrees. Those are the ones we're going to use a lot in here. But it pre-programs, your calculator knows that when you type in 30, the set walls are certain numbers. So it just divides them automatically. They're pre-programmed into memory. All right, questions with the cosine. We'll get to what these numbers stand for here in a minute. Like why it pre-programs, why it would give you a decimal. Perfect. Okay, and I think that number, it's like 0.866 or something like that. All right, and tangent, TOA. Tangent of an angle, so T. So tangent of an angle is the opposite over hypotenuse. So the opposite wall divided by hypotenuse, adjacent. So we're going to divide those numbers. So whatever the opposite wall is, you'll divide by adjacent wall. Whatever that fraction turns out to be, you'll simplify it, and it'll give me a decimal on your screen. Now, the purpose of it. Why do we actually have something like this? Because I kind of warned you of this. Right triangles are predestined. They have certain numbers for walls, like the relationships, the ratios of the walls. That's what your calculator is pre-programmed for. So it knows that when you have certain numbers for angles and certain walls, it can help you find the missing wall. The pre-programmed walls, the fractions in your calculator will help you. There's scales, and it will tell you what that scale is. Okay, that's what we're going to look at today. Okay, in fact, let's do the main three. The main three here. We'll try an example out. I'll walk around the room. We'll try it out. We'll try a second one, and then we're going to move on to the next three. Okay, these reciprocal functions, to make sure everyone knows how to type those in your calculator as well. Okay, now if you have not received a calculator, I'll let you get one here in a minute. You will definitely need one. I kind of warned you that this week that you'll need calculators and stuff coming up. This would be one of those weeks for sure, especially like tomorrow and Thursday and Friday. All right, but before you start moving around, let's take a look at an example of this. Okay. In fact, I'm going to put a picture up on the board when I'm talking about what we can use this stuff for. Now, does everyone have the formulas written down?
Yes.
Everyone has it, or at least you have it memorized, probably.
Yeah, I've written it down.
There. All right, let me get rid of it, and let me show you the example of what I'm talking about. There's two different ways, and I'll show you kind of the goofy ways to do this. So, and I'll show you why SoCalTel can be helpful. Okay, so here we go. Now, this is not going to be drawn to scale, but this will give you an idea what I'm talking about here. Okay. Okay, so if you're reading up here, I kind of pulled some different words from the book. So trigonometry is concerned with the relationship of angles and sides. So the sides and angles are predestined in a triangle if you have a right triangle. So without direct measurements, we can find heights of objects if we know specific numbers on a triangle. Specific numbers. Like on this particular example, we can find the height of the Eiffel Tower. Now that's obviously not drawn to scale, obviously, but yeah, it's way short compared to what it really is. But the idea is that we can think about this logically. Now what I mean by no direct measurements, I even put a little bubble here, is that I want you to try to find it without climbing it. So like let's say this is Bob here. Bob here could find the height of the Eiffel Tower by simply measuring his height and like climbing it. Yeah, it's like, you know, this we could say that this is a like what I heard there is 6 Bobs tall or whatever it is.
How tall is Bob?
Bob, let's say Bob is
5'7".
35.
Let's say he's 5'10".
He's a little tall.
Okay. Now obviously this is not the real Eiffel Tower. This is maybe some mock-up in like Vegas, but
This isn't the real Eiffel Tower.
no.
I thought you brought
The Eiffel Tower is like
700.
the Eiffel Tower is like 600 feet or something tall.
Oh, alright, figured it out. Boom.
All right.
That'd make it-
All right, but anyways, what we're looking at here is like, if you want to be realistic here, you could climb to the top, and this is, what is that? 7 Bobs tall,
A little less than 7.
right? You could do that in theory. Now that's not what I want to do, but you could in theory do that, okay? But that's literally what we're talking about here, without direct measurement. I don't want to climb up the tower with a tape measure. That's unsafe, especially if you've actually seen the real Eiffel Tower. Okay, so let me get rid of all these Bobs here. All right. That's one way to attempt this problem. Now, it's not the smart way. The smart way to do this is to actually think about a right triangle in this case. So the right triangle that I'm actually talking about here is this one. Okay? That you could do an angle of elevation, which let's say Bob measured the angle from the ground up to the top of the Eiffel Tower. That's called an angle of elevation. How you can do that? Your cell phone can do that, okay? Everybody's cell phone has a built-in gyroscope in it, and it can actually do angles. Now, on an iPhone,
Wait, do flip phones have that too?
Android phones do have that, yes. Now,
flip phones.
flip phones, I don't think so. Sorry, flip phones won't. Now, on an iPhone or Android phone, they always have the compass app. What a lot of people don't know is if you swipe to the side, it gives you a level.
Is that what that means?
Yeah. So it's if you were to place it on a desk, you could zero it out. In fact, I'm going to tap the screen. You can tap the screen and it'll zero out. And when you lean the phone, it'll tell you the angle on the screen. So if I place it on the ground and angle it up, it'll tell me, whatever angle I'm at. Now, obviously, I need to level this. So here's 0. If I lean up, it's telling me my angle's 45 degrees. And you can do this here. I can level it with the board, angle it up, and it's telling me that's about 40 degrees. Not 45, but again, it's a badly drawn picture. But again, anyways, the idea is that you can use your cell phone to find an angle on the ground. So point it up. Now, again, the phone has to be pointed at the top of the object, so you have to, it's called a line of sight. So you really have to get down on the ground and kind of line it up. Most line of sight problems, how you do this, other than just laying on the ground and finding it out, you find the shadow, like where the shadow is, and you just line up your phone so it's pointing at the sun, because the sun would be over here.
And then for the test, we can use this.
I love it.
Okay, there's my sun cloud. Okay, you can do it that way.
There's a cloud, how's there a shadow?
You still got sun poking out. You still got sun poking out there. But you can see the shadow of the Eiffel Tower, and that's where most people would measure. But you can do it from anywhere. You can stand anywhere you want from the object, put your phone down, measure up to the height of the object. And you just have to point to the top, and you have to get down really low, and try to be somewhat accurate. Because the more accurate you are, the more precise the measurement will be. Now, it is a right triangle, because we are trying to figure out the height of the tower itself. So it is a right triangle. And now, the other thing we can control is the actual horizontal distance, the horizontal, to the actual object. So that could be the shadow, the length of the shadow. It could be the number of footsteps you take towards it, because maybe you're not using a shadow, maybe you're just using a certain distance to walk there. And again, most people can figure out that distance by taking steps, like the stride you're going to take, or you can take your actual shoe and measure your shoe and take certain steps, one after another. But you can find the actual height of it. Okay. Now, again, I just do this picture up randomly because it's not accurate whatsoever. But again,
And then for the test, we can use our phones.
no, no, clever. No. All right. But anyways, but let's say you want to find the height of it, in which I pre-marked here as 324. But let's say that you went 45 degrees to the top of the tower. You were standing, when you took your steps, you were standing exactly 324 meters away. Maybe you measured it, you had a ruler, or you just measured your feet and you measured it out. But we can actually find this height without having to climb it because of these trig functions that I'm telling you. Okay, now to give you the idea here on this particular problem, maybe I want to find this height, right? How tall that is, the 324. But all I have is this wall here, and I have this angle. Well, this is my theta. This wall is the adjacent wall to me. The adjacent means closest, the one touching me. It's not my hypotenuse. And I'm finding the opposite wall to where I'm standing. Okay? So now I can figure out which one of the three trig functions. That's why there's three, because it depends on what setup you have, what angles, which walls.
Toa.
So on this one, I want to think about SOHCAHTOA.
You want to do Toa.
Yeah, you want to do TOA. Because TOA is the only one that uses the adjacent wall and the opposite wall. And so what you do is when you set up your formula, you're going to use that trig function I showed you earlier, tangent of whatever your theta is, my angle is 45. It'll be the opposite, which is x in my case, that's the height I'm trying to find, over the adjacent wall, which is 324 meters. Okay? And then to find the height of the object, because this is the setup, right? I'm using the formula that I showed you earlier. You plug in the numbers where they need to go, and since I only have one variable, I can solve this. And so to solve, you just do the opposite operations. Since they're dividing by 24, what's the opposite dividing? Multiply 324 times tangent of 45. And when you type that in your calculator, and again, you just type in on a scientific calculator, you type in 324, tangent 45, hit enter. If it's like a menu driven where you can see everything on your calculator. Now if you have one like, Dalton, hold yours up here. If you have one like the old Casio here, his it's not menu driven. He can't see everything that he types and then hit enter. He has to type in his backwards. He has to type in the 45, hit the tangent button because it will give you what the tangent of 45 is, and then take that times 324. So he has to go almost backwards. It looks like from almost everyone in here, you guys almost have all the same type of calculator. That one, Caleb, yours, you're gonna have to do it just like the Casio, type in it backwards. Can I see yours? Turn around. You'll have to do it backwards. Any other types of calculators in this room? Okay, I think yours is menu driven. I think you can type it exactly what you see here and then just hit enter and it should just spit out the answer.
It says 324 when I try.
Yeah, exactly, because when you type this in, it will give you the right height, which is 324. Okay, now, a lot of people think, oh, Ward, I must have typed it wrong, it gave me the same number. No, the reason why I picked this picture and I just made it a certain way, all the angles were equal in the triangle. So it's actually isosceles since two of the angles match. So these two walls had to be the same.
We didn't have to do any of that now.
So, what?
We didn't even need to do any of that.
No. But I'm just showing you that logically, some people actually try to do that. They try to stand at exactly 45 degrees away from an object where they're trying to measure the height. And when they're 45 degrees, that's the exact height of the object that they're standing away from. So it's a logical way to think about how to find the height of an object. you know, without doing all these calculations. They know if they stand exactly the spot that is exactly 45 degrees to the top of the object, the line of sight, they know that the distance they're standing away from the object is the same as the height. Okay, that might be too far though, because I told you, you don't have to stand at any particular distance away. You can measure it and plug it into your formula. Okay? All right, so let's do another example here. So let's say I want to find the height of a flagpole. Okay? Height of a flagpole. Okay, now flagpoles are usually default heights, but I want to find the height of it.
Showman, please come to the office. Also, Jamie from Athletico is here. If there are any freshmen or sophomores that need to see her, please go down to the locker room area at this time.
Okay, so here's your flagpole. Okay, now here's what I like you to write down. I like you to so when you're drawing this picture out, and I'm going to walk around the room and see this. I would like you to draw yourself over here. So here's you. You can pick any distance you want to stand from the object.
2 miles.
Okay, I don't care what you want to put. You want to put miles, you want to put feet, you get to pick that, do that on your own here. You get to pick that distance. Now, the only thing I'm going to tell you is right here, you have to pick a 30-degree angle. I'm not going to allow you to pick 45 or anything like that. Okay? So, you're going to put 30 there. And what I want is how tall this object is from where you're standing. And again, you get to make up the actual number for the distance away from it. Okay? I want to walk around the room. I would like to see your picture, and I want to see which trig function you're picking. And I want to see your numbers on your calculator. And I'm going to walk around, I'm going to check every single person in here to see that you know how to type it in your specific calculator, that you can actually find the right distance with the numbers you have. Does that make sense?
Yeah.
Now, I'm going to pre-warn you, I will have the camera in your face. I will try to not show you personally, but I'm going to show your paper and what your calculator says. Okay?
You can show me.
I'll pick a few people that want to do it. Okay, now, hey, that means that everyone does need a calculator in here. Everyone does need a calculator, because I will require that you are showing me the formula, and you're showing me how to type it in your calculator. Okay? We good? Alright, again, you get to pick that distance you're staying away from it. And it can be any distance. It could be 2 miles, it could be 10 feet, I don't really care. But you have to use 30, and I want to see it typed in. Okay? Alright.
X over 1776.
Okay. And then how would you type it in?
Oh, then I did this. Tan 30 times 1776.
I agree.
Sweet.
Okay. Alright, good. And you picked 30 degrees. And how do you get that 5.77 number? Tell me that.
Multiply that. 10 times tangent of 30.
Good. Yeah, and that's what you typed in your calculator. Perfect. Alright. Okay.
Sup?
Hey. So you picked 10 meters or 10 feet?
Yep.
Okay, so what's your formula then?
It's coming.
Alright, perfect. Keep going. We'll come back. Tori, let's kind of see yours. Okay, and then how do you get that 23 number?
I multiplied 40 times tangent 30.
Perfect, and that's what you typed in your calculator?
Yep.
Perfect. Alright, excellent. Okay.
30 shift. I don't know. Tangent.
I did 8,000.
Times.
Good. A lot of people are picking 10. Okay. How do you pick your number for your distance away? 1, 2, 3, 4. You just pick a random number?
Just wanted to write that.
Alright. And how do you get your x? What do you type in your calculator?
19, it's been the same.
Tangent 30 times 1, 2, 3, 4.
Okay. 3. Okay, and how do you get your number, your 15.58? What do you do there?
Took 27 times tangent
Why?
30.
Perfect. Alright, good. Yep.
Do you want to fight about it, white boy? I don't care. Stop.
Alright. And what are you going to type in your calculator?
Type it in my
Yeah, type it in. I want to see you actually type it in so I can see your number.
14, 10, 30.
My ear? Yeah.
Mine is 24
Perfect.
million
Alright,
feet.
good. And what's your label on that?
Meters.
Meters. Sorry, you want meters?
I had 1,176.
Okay.
And 1030.
Okay, Nice.
30.
And what was your label on your final answer?
Um,
What was your label?
oh, feet.
Yeah, you want to go with feet? Okay. All right. Nicole, you said you want me to ignore yours?
No, you can do it.
All right.
I have math.
You got math there? All right.
Yeah.
And how'd you type it in? Did you type that in your calculator?
Oh, I deleted it.
Just type it in again. I just want to make sure your 41 makes sense.
17.
I think I got it.
Okay. I agree. Okay. All right.
No thanks.
No thanks, that's fine. Just want to get your work on camera. You probably heard that pretty bad.
To edit that out.
Okay. Nice. Good.
Delete that.
Alright. Type that in your calculator. Perfect. Yep. Excellent. Good. Yours actually can do radicals in your calculator. That's really cool. That can do exact answers. Alright, good. Alright, so that's yours.
one chapter test.
Whoa! How did you pick that random number on the bottom?
What number?
That
That's
42
8,000 miles.
Oh, is that what you did? Just
Yeah.
8,000 miles. You converted it to feet? Is that what you did?
Yeah. So it's 4,000 miles tall.
Oh, because you converted back. Oh,
Yeah.
clever, clever,
It's
clever.
whatever.
Alright. And you picked 100 feet exactly? Okay, good. And then how do you type it in your calculator?
30 tangent.
That's good.
Good, so you type in tangent 30 and multiply by. Perfect, alright. Okay, now, it looked like a lot of people picked 10. It was just a random number. Okay, a lot of people picked 10 feet, that's fine, or whatever your measurement was. I heard some other numbers. Okay, now, here's the idea. How do I know what the answer is going to be before I start? Common sense before you start. And a lot of people were telling me how you type in, that's great, and all your numbers look correct. But before I start, here's something I want you to think about. Was this angle big or small?
Small.
It was pretty small, right? It wasn't 90, it's not straight up and down, it's kind of small, it's 30 degrees. So that means this wall has to be pretty small. The smaller the angle, the smaller the wall. In fact, there's a direct relationship of the angles in a triangle with how long the wall measure is. Because the medium angle is 60, so this would be the medium wall, and then the hypotenuse would be the largest wall because it's opposite the largest angle. So I can get a sense right now before I started that my x had to be smaller than 10, or whatever number you had, because if it's the smallest angle, that has to be the smallest wall, the wall that's opposite of it, wherever the smallest angle is.
Okay.
Okay? Now remember, triangles have to add up to 380. That's why I knew what the angles would be, since one of them had to be 90. Okay? Now, if this was not a right triangle, let's say that flagpole is leaning, you would not, at this moment, be able to find that wall length. Later on, bless you, there is a way to find it. Later, we have some other formulas if you don't have right triangles. But for right now, we have to deal with right triangles with the trig functions. Okay. Any questions with the trig functions themselves and the setup?
No.
Okay, or which one to pick? All right. Now, again, on the triangles, let me get rid of this drawing here. On the triangles themselves, it just depends on the wall you're trying to find. You know, if I was trying to find the cable to the top of the flagpole, that would be a line of sight cable. Maybe you're doing like a hilltop on top of a mountain, and you're on a ski slope, and you're trying to find the length of the cable going to the ground. Okay. Well, that means you need the angle with the ground that it makes. You need the angle that it makes with the ground, and maybe how far you're away from the pole, or away from the center where that mass is. That's kind of tough. What I would say, like if you're doing a ski problem, you probably know the height of the mountain itself. So maybe maybe you're up 6,000 feet. Okay. So that could be the way that you could find the length of the cable here itself. In fact, I would like you to actually try that. Let's see what trig function you can find to find the length of the cable. Okay, so think about SOHCAHTOA. So I want to find x, the length of it. Now, what's the label going to be? Feet. Okay. How do we know that?
Because the feet on the right side.
The other one's in feet. Now, is the number going to be big or small?
Bigger.
Big. It's got to be bigger than 6,000. The reason why, it's the hypotenuse. So I do want to see if you can actually find that specific number. Now again, when you're thinking about SOHCAHTOA, okay, you're thinking about the three main trig functions. These are the three we have pre-programmed on your calculator, right? we got to use one of the three. When I first started, like if you don't know, you do need to label. So this is made by theta, so whatever trig function, I'd be using my 20 degrees, okay? Now, what is this wall called?
Offset.
That's the opposite wall, so we know we have to use one of the two trig functions that use opposite.
Senior athletes that need to meet with Athletico can report down to the locker room area at this time.
Okay, so it's got to be one of those two. And what's the other wall that I'm trying to
Hypotenuse.
Yeah, I'm trying to find the hypotenuse wall. So I'm trying to find that wall. So that means I have to use this one. Question.
I have the answer.
Okay, I'm going to call it for it here in a minute. Now, we know that the number had to be bigger than 6,000. So Nicole, because you won the volunteer, is your number bigger than 6,000?
It is.
Okay, good. Now, the second thing is, did you use the sine function?
Yes.
Okay, good. So the sine of my angle says 20 degrees. Now, how did you set up your fraction behind it?
Okay, then I did 6,000 over x
Okay, good. Now, walk me through that. Why did you set up like that?
because it's opposite over hypotenuse.
Opposite over hypotenuse, the second letter over the bottom. And then what did you do after this?
I switched the x and the sine.
Good. Because if the variable's on the bottom, you have to multiply it across. And then basically the shortcut is you just switch them, right? Because that's an inverse operation. That will help you find x. And that's what you typed in your calculator, right? Now, the only hard part about this, I think Dalton, Caleb, I think yours, when you type this in, you actually need to find the sine of 20 first and write it down like 4 or 5 decimal places. And then take 6,000 and divide by that decimal. Like you actually have to like do 2 parts. There's no way to just type it backwards. It won't work. Okay, so for everyone else, you can just type it exactly how you see it and put parentheses in there. But for those 3 gentlemen that don't have those menu driven, you need to be very specific on that you have to find the decimal first and sine of 20, and then just take 6,000 divided by that number. Okay, now Nicole, what did you get?
17,542.8264.
Okay, 17,000, say again?
542.
42.8264.
8264.
Okay, and that is in, okay, and again, if that's in terms of miles, 3 miles-ish?
3.322 miles.
Okay, because 5,000 feet is roughly a mile, it's 5,280.
Yeah.
So I was expecting about 3 miles, 15,000. Okay. All right, 3 miles. All right, questions, comments about the problems we've been doing today? Okay, now, hey, tomorrow, we need to talk about these other 3, the inverse functions, to make sure you know it. We'll do a couple more of these where I'll make up some examples, and we have some other vocab words we have to throw in tomorrow, okay?
Mr. Murray.